Good evening, everyone. Welcome to live session 9 on the NPTEL course of Mechanics of Material. Today, we'll be discussing the topics covered in week 9 and we'll be solving based on those lectures. Okay. So, first of all, I'll just cover what are the important formulas and topics covered in week 9. Okay. So far in previous week, we have seen about the beam bending formula. So, the first formula what we saw is mg by izz is equal to sigma x by y minus y naught. We'll put minus equal to e by r. Okay, this was the beam bending formula we saw. Okay, in this, what are the assumptions we made? That e is what e is. E should be same in both compression and tension. That is homogeneous material. Okay, and loading is applied in the y direction. Suppose we have a beam like this. So our axis is like y and x, y and sorry, y, x and z. This is our coordinate system. So loading is applied in the y direction. So this is the first formula we saw. Then we encountered one thing, that what if the E is not same in both compression and tension, or what if the material is made up of composite? Okay, what do you mean by composite? When we have an element which is made up of two or more elements like steel or concrete material used. Okay, so then what is the formula we got? We got minus sigma xx by y minus y naught equal to d2 del y by dx square. This is nothing by 1 by r only. This is equal to mg by integration ey by, one second, here also ey, okay, y minus y naught square dax integration over ax. So this is the formula we got for composite sections. What was the section? Section will be like this. For example, suppose this section is made up of steel and this is made up of concrete. Am I audible? Hello?
Yes, sir. Yes, sir.
Yeah, okay. So, and we saw that E is inhomogeneous. Okay. So this we saw in the last week, and we saw how to solve the questions based on this. So similarly in this case also, the loading is applied in the y direction, same as above. The loading is applied in y direction. So now in this week, what we have seen is that what if when the loading is applied in other directions also? Here loading is applied in y direction. What if I apply the loading in z direction? Or what if the loading is not about the principal direction? What do you mean by principal direction? Is the loading is not applied in the CG. CG means cross section, centroid of the cross section. So what will be the formula? So when the load is not about the principal axis, and also when we apply load in y-axis as well as in z-axis. So what will be the formula? The formula we got is equal to, now one thing, when the load is applied in y direction, what moment you will get? Mz moment, and you will get deflection in y direction. So similarly, if I apply the load in z direction, what moment you will get? My moment, and you will get a deflection in z direction. Got it? So now here 2-3 cases will arise. How to calculate the deflection in y direction and z direction, and how to get the normal stresses. Okay, so the formula to calculate this thing is E d2 delta y by dx square is equal to Iyy mz plus Iyz my by Izz Iyy minus Iyz whole square. Okay, to calculate the deflection in z direction, the formula is Iyz mz plus Izz my by Izz Iyy minus Iyz square. Okay, and finally to calculate normal stress, bending normal stress, what we'll do? Nothing but y by dx square plus z minus z naught e delta z by dx square. Okay, so this thing you will get from this formula, and this thing you will get from this formula. Okay, okay. Now I told you in last problem solving session also that what is I by z. So here why I by z is coming out, because sections are not symmetrical. Okay, when the sections are symmetrical and the loading is about the principal axis, this I by z term is 0. So if you put here I by z as 0, you will get the answer as above cases like this. Like this answer you will get. Okay, since the section is not symmetrical and the loading is not about principal axis, you are getting a I by z term also. Okay, now we'll see the problem questions and we'll see how to do it. Okay, so problem, we'll start doing the problem. So what is unsymmetrical section? Which is not symmetric about any of the axes, or like either of the axes. Okay, so for example angle section, which you have seen in the class also. Okay, so suppose this is the angle section. Okay, so the dimension given is 90 mm, this is 100 mm, thickness is 10 mm, and this thickness is also 10 mm. Okay, and it is said that the loading has been applied not on the principal axis. Okay, at this point. W loading has been applied. Okay, at this point. Okay, what is the loading over principal axis means? Whatever the CG of this section, if the load is applied on that point, then it is known as loading about principal axis. Okay, since the CG will lie here, we'll calculate where the CG will come, and the loading is not applied on the CG. It is known as loading which is not applied on the principal axis. So we have to use this formulas which I have written just now. Okay, understood? So this W is nothing but given as that this loading is a UDL loading in a simply supported beam. Okay, so a simply supported beam is there. This simply supported beam has a cross section of angle. Okay, this leg it is given is L section is given, no. So the cross section of this is simply supported beam is angle section only. So a UDL is applied. This UDL. This loading is W, whose value is given as kilonewton per meter, and the length given as L, 8 meter. Okay, so I'll draw the first coordinate axis. This is as usual Y, this is X, and this is Z. Okay, so for this we'll assume this will start from the origin as bottom point Y, Z. Okay, till now understood all the things? Any doubt?
No, sir.
Okay, so this is the problem. Okay, now first thing, where is the load applied? You have to find out. It's acting on the y-axis. Okay,
Yes, sir.
you are clearly seeing it is applied on the y-axis. So mz moment is there. It will create mz moment. What about my moment? Since loading is not applied on the z direction, so my moment will be equal to 0. Okay,
Yes, sir.
got it? So when we use these formulas, okay, one second. So when we use these formulas as shown by the pointer, we put my as 0 because loading is not applied in the z direction. Okay, okay. So now we'll go step by step. So for this section, we have to go with the first thing is CG. Find out the centroid of the section and the moment of inertia. Okay, so we'll find out the centroid. First of all, this centroid of the cross section. Okay, we'll go with the y-axis. So y CG of the cross section. So what is the formula? It's integration of y dx upon integration of dAx. Okay, we saw in the last session also. Suppose I mark the element as 1 and 2. Okay, so we'll first calculate for the 1. So area of 1 is 100 into 10.
10.
Okay, and the CG of 1 in the y direction is 5 mm.
Yes,
Okay,
sir. T by 2.
yes, plus the area of second element is 90 into 10,
2.
and CG of second element in y direction is 10 plus 90 by 2. Understood?
Yes, sir.
Divided by the area, total area of element 1 and element 2. Okay, if you will calculate this, it will come out to be 28.6842 mm. Okay, now we'll calculate ZCG of the cross section. Similar formula, Z dAx by dAx. Okay, same. What is the area of first element? 100 into 10. What is the CG of element 1 in Z direction? 100 by 250 plus area of element 2 90 into 10, and CG of element 2 is in Z direction T by 2.
10. T by 2, 10. F5.
So 5. Okay, divided by total area of element 1 and element 2. So if you solve this thing also, you will get same answer, 28.6842. So why you got same answer? Because if you see, both the legs are of same height. See, 90 plus 10 is 100, and this leg 1 height also is 100 mm.
Yes.
Okay, that's why CG are same. Similarly, if you calculate the moment of inertia, they both will come out to be same. I'll solve both. You will see. Okay.
सर
So-
वो 50 कैसे हो
Which thing? This one.
हाँ
See, first element. Okay. Area is 100 into 10. Okay.
Yes, sir.
CG of element 1 in Z direction.
Oh, sir, 100.
Yeah, 100 by 2 is 50.
Yes, sir. 50.
Okay, got it.
Yes, sir.
Okay. Now next is moment of inertia. I'll copy this figure first. Okay. So moment of inertia. First we'll calculate about IY axis. Okay. So
मतलब y
parallel,
direction.
yes, y direction. So you know parallel axis theorem. I told you in previous class also. What is parallel axis theorem? IYY of cross section is equal to IYY of element along CG. Okay. Plus A y minus y naught square. Okay.
Yes.
This is parallel axis theorem. So IYY of cross section will be equal to. So first element will do. What is IYY of CG of element 1? Is nothing but 100 into 10 cube
10.
by 12.
Yes, sir.
Okay. Plus area. What is the area? 100 into 10.
Into 10.
Okay. Now what is the CGB calculated for y-axis? 28.6842
28.6. Yes, sir.
minus what is the CG of first element in y direction? 5. Okay.
Yes, sir.
Square. Okay. Plus now we'll go to second element.
Sir, ये whole square है ना?
Yes, whole square. This is.
Yes.
Second element. What is the IYY of element CG? Is 10 into 90 cube by
90 cube by 12.
yes. Plus area 90 into 10. Okay. What is the CG of second element in y direction? It is 55. 10 plus 90 by 2 minus CG we have calculated. Okay. Whole square. Okay. Any doubt?
No, sir.
This 55 is nothing but 10 plus 90 by 2. Okay.
Yes, sir.
So if I calculate this thing, what I will get 1.8 into 10 to the power 6 mm4. Okay. Similarly, I will calculate for y-axis. Cross section. Sorry, I is easy. Same I is easy of element along CG plus A into Z minus Z naught square. Okay. So we'll go. What is for first element? It is 10 into 100 cube by 12 plus area 100 into 10. Okay. What is the CG of first element in Z direction? 50 minus what is CG we calculated for cross section? 28.6842 square plus for second element it is 90 into 10 cube by 12 plus area 90 into 10 plus CG we calculated minus CG of element 2 5 square. Okay. Any doubt?
No, sir.
One thing I'll tell you. Why here I have taken 28.6842 right hand side and here I have taken first. See, the motive is we will take distance as positive. Okay. The subtraction should yield positive value. Okay. See, if you subtract 50 minus 28.68, it will come as positive number, no? You are getting it or
सर,
not?
अगर वो वैसे भी निगेटिव या पॉजिटिव है, अगर उसका स्क्वायर करेंगे तो पॉजिटिव ही तो आएगा.
No, see, here it won't affect. But when you calculate IYZ, it will cause effect, okay? Next, I'll calculate that thing only, then you will understand, okay? So, make sure that you are taking distance as positive, okay? Got it?
Yes.
So, now we'll calculate IYZ of the cross section. So, same as per the parallel axis theorem, IYZ of element along CG plus A into Y minus Y naught, Z minus Z naught. Okay. So, one more person joined today, Santhya. Are you able to hear? Hello, Santhya. Okay, I guess voice is not audible to her. We'll proceed. Okay, is it audible now?
Yes, sir.
Yeah, maybe have mic problem. So we'll go ahead with IYZ cross section. Then, so what I told you previous class also, IYZ along CG is always 0. Okay. So now here also we'll go with the element 1 and 2. So now you see the difference. Why I am taking telling you to take distance as positive. See, area of first element is 100 into 10.
10.
Now, what is the YCG is? We calculated 28.6842.
Yes, sir.
Minus what is the CG of element 1 in Y direction? 5.
5.
Okay, same as in Z. What is the CG of first element in Z direction? 50.
50.
Minus 28.6842. This is we have calculated for cross section.
Okay, sir. Understand.
Now, if you take other way around, it will come as negative. You are getting it?
Yes, sir.
So always try to take positive distances. Then you will get almost correct answers. Okay, always correct answers.
सर मेरा अगली बार असाइनमेंट का सारा पॉइंट की वजह से सारा का सारा आंसर ही गलत होगा.
हाँ, so just you make sure like you are following the correct steps. Okay. Plus for second element, same thing. 90 into 10. This is the area. What is the CG? 55 minus 28.6842. It's in Y direction. And this 28.6842 minus 5. Okay. So after calculating, you will get 1.06578 into 10 to the power 6 mm4. Okay. Understood?
Yes, sir.
So far we got this values. I'll write in one. YCG for cross section 28.6842 mm. ZCG for the cross section same. Okay. IYY cross section 1.8 into 10 to power 6 mm 4. IZZ cross section 1.8 into 10 to the power 6 mm4. And IYZ, yes, it will come out to be same. You can calculate by your own and see. See, if the CG
Yes,
is
sir.
same,
Yes, sir. Yes.
if the CG
Yes,
is same, then and the cross section is also same about both CG. So all the values will come out to be same. Okay. And IYZ will be 1.06578 into 10 to the power 6 mm4. Okay. Okay. Now one question. Now the questions comes. Okay. How to solve? First question comes as, what is the orientation of neutral axis. Sorry, principal axis. Neutral axis will solve later. Okay. Principal axis. So the formula to find out this thing is theta is equal to 1 by 2 tan inverse twice of IYZ upon IZZ minus IYY. Okay, this is the formula. So in our case, IZZ and IYY are same.
Yes, sir.
So it become infinity. This and tan inverse infinity is nothing but 90 degree.
Yes, sir.
So theta will be equal to half of 90 degree, which is equal to 45 degree. So orientation of principal axis is in 45 degree. Okay, from CG. So I'll just draw how it looks.
सर लेकिन अगर जिसमें थीटा
Yeah.
दिया हो ऑलरेडी तो
So you calculate IYY and IZZ, you will calculate from that, na? They must have mentioned something else also there. If theta is given to you, then they will say like we have given you the value of IZZ and IYY and theta value is also given, then find out IYZ from that. Understood?
Okay, sir.
So I will tell you how this theta will portray here in the figure. See, this is CG. Okay. So here, this is our y-axis. This is z-axis. Okay.
Yes, sir.
So it is in the direction of this 45 degree. This is 45 degree. Understood?
Yes, sir.
So this is the principal axis. Understood how it is looking like? So now second question. So now second question comes. We have to calculate the deflection in y direction, z direction. Since the loading is not about principal axis, so we will get both the deflection in y direction, z direction. Okay. So what is the formula? I wrote earlier also what formula we will use. These two formula will use. This formula and this formula. Okay.
Yes, sir.
So I'll just copy paste this thing first. So this is the formula we'll use to calculate the deflection in y direction, z direction. Okay.
So in our मतलब sir displacement ना?
Yeah, deflection is similar to its displacement. In higher terms, it will be differ, but right now for you is same. Okay.
Okay.
Deflection means that if a simply supported beam is there, no, so it will deflect like this. So what is the maximum deflection? This is del y. Okay. So in your case, it will deflect in z direction also. Okay, I cannot draw a 3D figure here, but it will deflect in z direction also. Okay, understood? So how to find these two values? Okay. So in our problem, my is 0. Okay, because the loading is applied in the y direction. So we will get mg moment. Okay. So this two formula, if I put my as 0, it will become IYY by IZZ IYY minus IYZ square into mz. Okay. And second one will become minus IYZ upon IZZ IYY minus IYZ square to mz. Okay. After putting my equal to 0, the formula comes out to be this. Okay.
Okay, sir.
So now in the question, what they have given to us? that this is the simply supported beam. Okay, and UDL is applied. W, whose magnitude is 0.1 kilonewton per meter, and length is also given as 8 meter. Okay, so I won't go to detail the how to find reactions and moment equations, okay, because it is covered previously many times. So I'll tell you in short. If you don't know, you just tell me, I will solve again, okay. See, this structure is symmetric, loading is symmetric, so reaction will get this A point and B point. So RA will be equal to WL by 2. Are you getting this point, or shall I solve to show you how you are getting this thing?
होगा sir. RA is equal to WL by 2. Yes sir.
Okay, since loading is per unit length, so you will multiply by L, and so it will become WL. So since it is symmetric, it will distribute half-half. So WL by 2 and WL by 2. Got it?
Yes sir.
So, okay. Now, what is the mg moment expression you will get? So, suppose if we go to x direction like this. So, RA into x. Moment is nothing but force into lever arm. So, here I'll start from A point. Okay. A point force is applied as RA. Okay. And
Yes,
lever
sir.
arm is x. So, RA into x. Now, minus opposite direction, W is acting, load W is acting. Okay. So, W into x, that is the load. This is load because it is in per meter, no?
Yes sir.
Into, it will act at half point. Okay. X by 2. Okay. You get this point, or see, in UDL,
Yes.
this UDL can be converted of length L, can be is equivalent to point load at L by 2. Okay.
Yes sir.
So we are applying this UDL at X. Okay. So it is equivalent to point load at X by 2. So this point load is nothing but W into X, and lever arm is X by 2. Got it?
Yes sir.
So that's why this moment expression coming out to be. Okay. So I'll put the value of RA as WL by 2x minus WX square by 2. So it will become WX by 2 L minus x. What is the range of x? 0 to 8. Okay. So this is the expression of mg. Okay. Now, if we have to put in this expression, so mg we know, Iyy, Izz, and Iyz we know. So just I am putting the values and writing the expression. Okay.
Okay sir.
So I'll just copy paste so that you won't fall. Copy. Paste. Okay. So now I'll put value one by one. So different color. E d2 del y by dx square. Iyy is 1.8 into 10 to power 6 upon 1.8 into 10 to power 6. 1.8 into 10 to the power 6 minus 1.0675 to 10 to the power 6 whole square, and mg is wx by 2 L minus x. Okay. Okay. This thing. So if I will solve this thing, I will get this as 0.855 into 10 to the power minus 6 wx by 2 L minus x. Okay. Similarly, I'll put E d2 del z in z direction, which will be equal to minus of 1.06578 into 10 to the power 6 upon. Till now you understood all things, no? If any doubt is there, you tell me, I'll repeat. Okay.
Okay, sir.
Okay. So after calculating, you will get minus 0.5065 into 10 to the power minus 6 wx by 2 L minus x. Okay. So this I will take. I will not write again this value. So I will just take as k1 wx by 2 L minus x. Okay. We'll put value of k1 afterwards. Okay. And this as k2 wx by 2 L minus x. Okay. K1 is 0.855 into 10 to the power minus 6 and K2 is minus 0.5065 into 10 to the power minus 6. Okay.
सर ये W(x/2) L minus x को
Yeah.
आपने K1 K2 कर दिया.
No. This value.
Okay, sir.
This value is K1 and this value is K2. Okay. Multiply by this thing. Okay. This thing is same. Okay.
Okay, sir.
Okay. So now we have to calculate what you have to calculate del y and del z. Okay, this we have to calculate. So for this we have to integrate twice. Okay. So first I'll go with delta y. If I will integrate twice, what I will get? K1 W L by 2. 1 second. K1 W by 2 I'll take common. Okay. Here it will come Lx cube by 6 minus x4 by 12 plus C1 x square plus C2. Any doubt in this? How I got this thing?
Yes, sir. एक बार और सुनाइए.
So I'll explain this thing. Okay. So our expression was K1 Wx by 2 L minus x. Okay.
Yes, sir.
So I took K1 W by 2 as common. So I will left with Lx minus x square. Okay.
Yes, sir. Yes,
So
sir.
now I have to integrate twice. So first we'll do first integration. So we'll do integration. So x become x square by 2
Yes, sir.
and x square will become x cube by 3 plus integration constant 6c1. Okay.
Yes, sir.
Now again we'll do integration. So x square by 2 will become x cube by 3. 3. So 3 into 2 is 6. Okay.
Six. Yes, sir. And
Minus x cube become x4 by 4. 4 3 is 12.
12.
C1 will become C1x plus integration constant C2. Okay. That's how we got. Got it?
Yes, yes, sir.
So I'll remove this part. So similarly for delta z also we will get K2 W by 2 Lx cube by 6 minus x4 by 12 plus d1 x square plus d2. Okay.
सर अगर d1 x स्क्वायर है तो d2 x होगा
Oh, sorry. D1, sorry, C1 x will be there, not x square. Good.
ओके सर.
And D1 x, sorry. Okay, good. So now we'll see. We have two unknowns. Okay, so we need two equation for each one of them. Okay. So suppose, see, we have a simply supported beam. So what are the boundary condition we got? See, for simply supported beam, this is our simply supported beam. Okay, UDL is there. Okay. Okay.
Yes, sir.
So deflection will be 0 at here and here. Okay.
Okay.
So it will be both. It will be same for both z and y direction. So delta y at x equal to 0 is equal to delta y at x equal to L. is equal to 0. Similarly, delta z at x equal to 0 is equal to delta z at x equal to L is equal to 0. Okay. Because we are saying our both x and y direction are simply supported. Okay. In question, in paper also you can get like, they will say that in y direction it is simply supported, whereas in z direction it is free end. Suppose, for example. So then in y direction you will apply this formula, but in z direction you cannot apply because it is not simply supported then. Okay.
Okay.
But in our question it is said like both are simply supported. So we'll use this thing. Okay.
Okay.
Now if we put one by one, we'll put delta y at x equal to 0. If we put, we will get c2 equal to 0. Okay. Similarly, in delta z also, if we put x equal to 0, we will get d2 equal to 0. See here, all are x dependent, no? So this
Yes,
all
sir.
will go 0, only d2 will be left, which is equal to 0 only. Okay. So this 2 will be 0. Now we'll put delta y at x equal to L. Okay. What we will get? We will get C1 as minus L cube by 12. Do you want me to solve this in a steps or you are getting it? Okay, I'll show you in steps this thing.
Okay, sir. Yes, sir.
See here you put this thing L. Okay. So this delta z is 0 at L. So our left hand side becomes 0. K2W by 2. Inside you put L. So it will become L4 by 6. This become L4 by 12. D2 is 0. We got it with the first boundary condition.
Yes,
Plus D1L. Okay. So see, this right hand side is equal to 0. So this will be 0. So
Yes,
L4 by 6 minus L4 by, one second, L4 by 12 plus D1L is equal to 0.
Yes, sir.
So take LCM, D1L plus 12 you take, L4 equal to 0. So D1 become minus L cube by 12. Understood?
Yes, sir.
Got it? Similarly for delta Z also and delta Y also. Okay.
Yes, yes, sir.
Okay, now we'll go ahead. Okay. So now we got all the four unknowns. Okay. So now I will put the value. So E delta Y will become now K1 W by 2 L x cube by 6 minus x4 by 12 plus L cube x by, sorry, minus L cube x. This I am putting this constant value C1 D1 C2 D2. Okay.
Yes.
Okay, this is E delta Y and E delta Z will become K2 W by 2 Lx cube by 6 minus x4 by 12 minus L cube x by 12. Okay. Now this is the expression. Okay.
Yes.
Now they will ask you where you will get maximum displacement. So in simply supported beam, last week also I told you you will get the maximum displacement at midpoint. So in simply supported beam, maximum displacement will be at midpoint. Okay. So in our, that is at L by 2. Understood?
मैक्सिमम डिस्प्लेसमेंट मिड पॉइंट मतलब y डायरेक्शन में सर
both direction, क्योंकि दोनों both are simply supported, no, in y direction and z direction.
ओके सर
So in both the cases we will get maximum displacement at L by 2. It is universal truth, like in simply supported beam it is always at L by 2. In cantilever,
L/2
yeah,
और सर L तो दिया 8 मतलब हो जाएगा आपका 4
yes, okay. In cantilever maximum displacement you will get at free end. This is always true, okay. So now we'll put the value of x equal to L by 2, okay. So E del y max, we will calculate what we will get, K1 W by 2 L4 by 6 8 the 48 minus L4 by 16 12 the 16 12 the will be 192 minus L4 by 24. Okay, if you put x equal to L by 2 you will get this thing, okay. Now taking LCM you will get K1 W L4 5 by 384 E del y max, okay. This you will get, okay. Understood or shall I explain more?
सर ये मतलब क्या निकाले हैं
Maximum displacement in y direction.
मैक्सिमम डिस्प्लेसमेंट इन
See, here we got the expression of displacement of y, okay.
यस सर ये सिंपली सपोर्टेड बीम मैक्सिमम डिस्प्लेसमेंट
Yes, in y direction, okay. So now maximum displacement we will get at L by 2 location.
यस सर
So I am putting x as L by 2.
तो मतलब सर अभी मेन आंसर ये नहीं L/2 नहीं है
L by 2 is the location, okay. If they will ask you what is the location, it is L by 2. If they will ask you what is the maximum displacement, so you have to put this L by 2 in this expression, okay.
ओके सर
So when you will put x by 2 in this expression you will get this, okay. Finally if you take LCM you will get this, okay.
ओके सर
So now I will put the value, okay. So K1 we assumed as 0.855 into 10 to the power minus 6, if you remember. This is K1. One second, where I put K1.
यस सर K1 is equal to था सर
Yeah, K1 is this. See, K1 is this, okay. So this is 0.855 into 10 to the power minus 6, okay. W given as 0.1 kilonewton per meter, okay. So 0.1, see, 0.1 kilonewton per meter is equal to 0.1 newton per mm also, okay, because we are taking all the units in mm and newton, okay. L is 8 meter, which is equivalent to 8000 mm to the power 4 upon 384. E is given as 200 GPa, which is equal to 200 into 10 to the power 9 Newton per meter square, which is equal to 200 into 10 to the power 5 Newton per mm
लेकिन
square.
L तो 8 मीटर
Meter, so meter, yeah, we have changed to mm because we are taking all the units in Newton and mm, that's why, okay. Be consistent with units also, otherwise you will get wrong answer. So always I am writing like this, 200 GPa means 200 into 10 to the power 9 Newton per mm, Newton per meter square, which is equivalent to 2 into 10 to the power 5 Newton per mm square, okay. So E is 2 into 10 to the power 5 Newton per mm square, okay. So finally you will get del y max as 31.50 mm. This is the value of displacement, maximum displacement in y direction. Got it? Oh, sorry, I have to calculate this one. I didn't calculate it. I calculated for z direction. This I have to calculate. Okay.
वो सर किसके लिए कैलकुलेट किए थे?
del z in z direction. We'll solve for z direction also, na?
Okay,
See,
sir.
you got two expression, na? In y direction and z direction. So now we are calculating for maximum displacement in y direction, which
Yes,
is
sir.
at L
फिर
by
वहाँ
2.
K2 का रख के
Yes, we have to put K2 value. Both will be different value. I'll just calculate and tell you the answer. 1 second. Give me
Okay.
some time. 1 second. Meanwhile, you can also calculate. We can cross check the answer.
5 into five into 0.5.
One thing we did wrong here. What is the answer you were getting?
Sir, wait 1 minute.
Yeah.
384. Sir, 2.28 into 10 to the power 30.
No. 22.8 you will get.
22.8? Yes, sir.
How? See, this 10 to the power 5
Oh,
will go
sir,
above.
mm में है ना? Oh, sorry, sir, ये millimeter.
So, okay. Check, okay.
Okay, sir. सर मैं पूरा वैल्यू रख के कैलकुलेट किया हूँ तो 2.28 आ रहा है
2 point.
वैल्यू रखने के 2.28
Okay, you check, okay. See,
क्योंकि
okay.
सर मैं इसको
You can cross check also. Yes, no issue. You can cross check also. Okay. See, this procedure should be correct. Answer you can check afterwards also. Okay.
Okay, sir.
Now we'll calculate delta z also. Okay. So similarly, E delta z maximum will be at L by 2. So we will get same answer after putting x as L by 2. 384 E. Okay. But this K1 is K2 now. Okay.
Yes, sir.
Understood. And this will become C. If you do this LCM, no, take this LCM, it will come out to be negative. Okay. So you will get negative displacement in Z direction. Okay. So how it is making sense? See, in simply supported, if you put a load like this, it will deflect like this. and our axis is y as this, z as this. Okay, sorry, y is this, z is this, and x is this. So you will get deflection in like this direction.
Yes, sir.
So this is negative y only, no? So that is why you are getting a negative sign. Okay.
Minus 22.8.
Yeah.
Yes, sir.
So here also when you will take LCM, you will get minus. Okay. But your K2 is also minus. Minus 0.5065 into 10 to the power minus 6. We took there this thing, na? K2.
Yes, sir.
This is K2. This K2 is minus 0.5065 into 10 to the power minus 6. Okay.
Yes, sir.
So minus minus will become plus. Okay. Into same 0.1 into 8000 to the power 4 upon 384 into 2 into 10 to the power 5. Okay. So now you will get delta z in z direction. You will get 13.50 mm. Okay.
Okay, sir.
Understood how to calculate deflection
Yes.
in z direction, y direction?
Yes.
How to get maximum value? Okay. So these two are done. Okay. Now we'll go to next
Sir.
question. Yes.
सर एक क्वेश्चन है, फाइंड द magnitude of displacement along the y direction at mid span.
Yeah, that is the same thing what we have calculated. Mid span means mid value. Yeah, that is the same thing. In y direction means delta
y direction. हाँ, और z का ये हो गया.
Yes.
तो location
is mid span only, L/2, no?
फिर location of maximum magnitude displacement from hinge support.
हाँ, so it's L/2.
Hinge support का L/2.
Yes, see, this is simply supported beam, no? So what is this support called? These are called as hinge support. We are calculating at midpoint.
ये हम लोग जो डेल्टा y और डेल्टा z निकालें वो मिड पॉइंट का लोकेशन निकालें.
Maximum value.
Magnitude of displacement.
Maximum value lie will occur at L/2.
सर इस क्वेश्चन में लेकिन मैक्सिमम नहीं लिख रहा है. Magnitude of displacement along.
See, this is the general expression. This is okay. Here x varies from 0 to 8. Okay. So maximum value will lie when x is equal to 4. That is L/2. For maximum. Okay. For any other value you have to put. See, at hinge support, if you put x equal to 0, you will get deflection 0. True. If you put at L, you will again get 0. Which we have assumed also. Okay.
Okay, sir.
So this is how you have to, this is the general expression. So to calculate maximum, you have to put x equal to L/2. Got it?
और ये magnitude of displacement along
magnitude is this. This is the magnitude only, 13.50. This is what magnitude.
Okay, sir, यही confirm करना था.
Okay, got it?
Yes, sir.
Now next question will come. What is the maximum bending normal stress set to tension? Okay. I'll just copy paste the figure to let you understand this thing. See, this is our figure, okay? Okay. And this will be our neutral axis. I'll change the color. Okay.
Okay, sir.
So in the lecture also, if you have seen that bottom part is always in tension, top part is always in compression. Okay. So maximum tension will occur at this point. Okay.
Okay, sir.
You can revisit the lectures also to know for further details how it is there. Okay. In this point you will get maximum compression. Okay, I'm telling you so that in the paper if they ask you, you know where is the location. Okay, this is for maximum tension. Okay. Okay. So location of this is, see, we assume origin is this point only. So y is equal to 0 and z is equal to 0. This is the location where you will get maximum tension. Okay. If they have asked you what is the location of maximum compression, your y will be equal to 100 and your z will be equal to 0. This is the location of maximum compression. Got it?
Yes, sir. Once.
How to find the location?
Yes, sir.
Okay. As per the coordinate system we have assumed. Okay.
Okay, sir.
So what is the formula for sigma xx? I have written in the first only. I will write again. Minus y naught e d2 del y by dx square plus z minus z naught d2 del z by del x square. So now sigma xx max in tension. Okay, you have to find out. Okay.
Yes, sir. Yes, sir.
For this, I will change the color. Y is equal to 0, Z is equal to 0. Okay. I told you how you got this thing. Okay. Any doubt in this?
ये सर दोनों डायरेक्शन मतलब आंसर 0 हो जाएगा.
No, answer won't be 0. See, we have to put the values na here in this expression.
Yes, sir.
So for this y and z equal to 0, the location of this is this. That's why 0 0.
तो ये always रहेगा.
Not always, for this section, for this example. For angle section you will get maximum tension at bottom point only.
सर लेकिन इसके जहाँ पे जो 1900 है अगर वैल्यू चेंज होगा तो आंसर भी
value change doesn't differ. See, only shape and the location neutral axis. For this neutral axis location will be always like this only. Okay.
Okay, okay, sir.
So you will get maximum tension here and maximum compression here. Okay.
तो मतलब सर क्या कहना चाहते हैं एक बार बता दीजिए.
So here in the question
अगर इसमें वैल्यू चेंज रहे.
So it won't change. It won't change. It will be same.
Okay, sir.
Doesn't depend upon value.
होना चाहिए.
Yes. Yeah. Shape should be like this. Okay.
Okay, sir.
Got it?
Yes, sir.
Okay. Now y naught is nothing but it is CG. Y naught CG of cross section. Okay.
Yes, sir.
Which is 28.6842
685
mm. Z naught is also CG, which is same. Okay. And this value we have already calculated.
Yes, sir.
K1 Wx into by 2 L minus x. This is also K2 Wx L minus x by 2. Okay. So they have asked for maximum. So where the maximum will occur? L by 2. So
yes,
L will be equal to L by 2 for maximum. Okay. So if you will put the value, you will get K1 WL square by 8. Okay. Here you will get K2 WL square by 8. Okay.
X के जगह पे L by 2 कर दिए.
Yes,
sir.
Got it? So now you got all the things. Just put here. Okay. So sigma xx max tension. You will get minus. Okay. Y0 minus will become plus 28.6842 into, we'll put K1 as 0.855 into 10 to the power minus 6. W is 0.1. Okay. L is 8000 square by 8. E is 2 into 10 to the power 5. Okay. Plus Z minus Z naught minus 28.6842. K2 is minus 0.5065 into 10 to the minus 6. W 0.1. L square is 8000 square. E is 2 into 10 to the power 5. Okay. After putting all the values, you will get sigma max xx in tension as what you will get answer. After calculating, you will get 31.25 Newton per mm square. Okay.
Yes, sir.
Till now, any
लेकिन
doubt?
हमने उसमें पावर एट नहीं किया.
Which? Where?
ए प्लस के बाद ये लास्ट 0. minus 0.5065 into 10 to the power minus 6 into 0.1 into 8000
By 8, हाँ, divide by 8 also.
Yes, sir.
Yeah.
आपने वही बोला.
Typo mistake, yeah. Divide by 8. Good, good. Okay, same thing. Okay, you have to put the values. Okay.
Yes, yes, sir.
So till now, any doubt in this thing?
No, sir.
So this is all they will ask you in the question. Okay. Now I'll tell you what is the now. Okay, one thing also I will solve. Next is orientation of neutral axis.
Orientation of neutral axis, yes, sir.
Okay. So what is the formula? Y minus Z minus Z naught upon Y minus Y naught equal to 10 beta equal to IYY MZ, because MY is 0, so I am not writing that term. Okay, you can see the notes for the formula, full formula. For our case, this is the only formula required. Okay.
Yes, sir.
So MZ will cancel out MZ.
Yes, sir.
IYY is 10, 1.8 10 to the minus 10 to the 6.
Yes, sir.
1.057. Sorry, 1.0657. 6. Okay. So 10 beta. Sorry. So beta will be equal to 10 inverse. 1.8 upon 1.0657. 10 to the power 6 will cancel out. Okay.
Yes,
So
sir.
beta will be equal to 59.37 degree. So this I have drawn this axis pink color. This angle will be equal to this only, beta. Okay.
Yes, sir.
Understood?
Yes, sir.
See, now loading is applied here in W like this. Okay. So you got delta Y and delta Z, all these things. Okay. Now in your assignment problem, I'll copy all. It is applied like this. W.
Yes.
Okay.
Yes, sir.
What you will do?
Direction.
No, see. This is your Y and Z, no?
Yes, sir.
You just resolve it into U and V. Okay.
Okay, sir.
So now see, W is applied on V direction. So you will get MU moment. Okay. And MV moment will be equal to 0. Okay.
Okay, sir.
Because W is applied in V direction. Also, since U and V are principal axis, so your IUV will be equal to 0. Okay.
Okay, sir.
Because it is loading is applied on principal axis. Okay. So your this expression will become to delta. Sorry. delta U by del X square will be equal to MV by MU by MU by IUU. Okay, understood. See, this is will same as simple bending. Okay, simple bending expression. This is simple case only.
Okay.
Because it doesn't involve this much of calculation. Like, see, we have calculated this thing, na?
Okay, sir.
This expression, this one. See, this is typical. Here, if you put IYZ equal to 0, you will get same as what I have wrote here.
Okay, sir.
Okay. So, moment you can calculate as per the diagram, simply supported UDL you can find out. IUU you can find out. Okay. E will be given, then you can integrate twice to get the answer. Okay. Understood? How to solve assignment question?
सर इसमें दो क्वेश्चन दिया है.
Yeah.
Rotation, clockwise rotation about Z axis and Y axis.
Yeah, see, this rotation is nothing but what? Anti-clockwise rotation. U from Y.
Clockwise, yes sir, अभी anti-clockwise नहीं लिखा. एक में clockwise, एक में anti-clockwise.
So then if anti-clockwise even, then you have to put like this. Understood?
कौन सा सर?
This dotted line. Okay.
Okay, sir.
Understood this question what I have solved today?
सर तो इसका फॉर्मूला क्या होता है क्लॉकवाइज और एंटी क्लॉकवाइज का?
Formula will be same. Okay. Only rotation will change.
Okay, sir.
Okay. See here, if you will, for this question only, if you will resolve this Y, if this is theta, if this is theta, then Y, what Y will be? Y will resolve as Y cos theta. Okay.
Okay, sir.
And here it will resolve as Y sin theta. Okay. So for V, it is equal to minus Y sin theta or not? And for U equal to plus Y cos theta or not? This is Y direction.
Yes. Yes.
But if you put clockwise direction, I'll solve this. Okay, if you put like this direction, this theta angle, okay, so this will become Y cos theta and this will become Y sin theta. So now your V will become minus Y cos theta and your U will become Y sin theta. Okay. Only this thing will change, okay, as per the orientation. Got it?
Okay. Okay.
So this is there. Okay.
Okay, sir.
So this is all for today's class. I hope you have understood all the steps. You can go through each and everything. Okay.
सर एक आखिरी क्वेश्चन
Yeah.
है. ये जो आप रो रिकॉर्डिंग.
Okay, so if it's there with this lecture only, so I'll take it with the lecture. If it's something else, I'll just stop the recording and we'll take the.
नहीं, लेक्चर का ही है.
Then you can ask now.
ये जो आप इधर RA और RB निकाले थे इस क्वेश्चन में.
Yes.
असाइनमेंट में भी सर सेम वैल्यू दिया है, तो आप जो L/2 निकाले हैं वो बस इस पार्ट के लिए L/2 निकाले हैं ना?
For which part?
ये मतलब ये जो आप स्क्रीन पे रखे हैं.
Yes.
ये सेम वैल्यू मतलब जो W है, L है और जो है ये मतलब इस हिंज के लिए.
It is always to see how it is true, like always. See, W is there. Don't go with values. W is there. It is in per meter. So I told you na. See, this is equivalent to this thing. at L by 2 or X by 2, whatever the length is there. So Wx is point load. Okay, applied at midpoint. So it will distribute load equally in both the endpoints.
नहीं तो सर तो मैं ये कह रहा हूँ जो डेल्टा वाई मैक्स है और डेल्टा जेड मैक्स है तो वो तो आपने ही इसमें निकाल के हम लोग को बता दिया
Yeah.
यही ना मतलब मैं ये कहना चाहता हूँ जो आपने आंसर निकाला सेम आंसर तो हम लोग के
Yeah, if the see that delta y delta z max are will be same if the beam is simply supported.
ओके सर
Simply supported means you have a maximum deflection at midpoint.
ओके सर
If a beam is cantilever, suppose you will get maximum deflection at free point, that is end point. Getting it?
क्योंकि मैं सर अभी असाइनमेंट खोला हूँ तो देखा हूँ
Yeah.
वैल्यू तो सेम आ रहा है
Okay.
तो आपने जो ये मिड पॉइंट हो गया और डेल्टा वाई मैक्स डेल्टा जेड मैक्स आपने तीन का तो आंसर बता ही दिया इसमें हम लोग
Yes.
ओके सर
You got it?
यस सर
Okay, bro. Any else? Anything else?
नो सर
Okay, bro. Then I'll stop the recording. Thank you for joining the class. We'll see you next week.